Imagine this traveller you didn't arrive here by chance. Something in the quiet machinery of the cosmos seems to have led you to this moment to this question. An object the largest interstellar visitor ever detected is moving through our solar system in complete silence. On October 29th, it slipped behind the sun for 3 hidden weeks, the perfect blind spot. And what are the odds that it returns to view just before December 15th, the day it threads past Earth's orbit, with a 1 in 20,000 precision? A faint smudge drifting past the edge of Mars, a light that flickered once, and never again a pattern in its path that shouldn't exist. Let's drift a little deeper. Imagine this traveller, a quiet July night, unremarkable in every way until a single pixel on a sky survey monitor shifted ever so slightly. Not a streak, not a flare, not a warning. Just a faint point of light wandering across a sensor that had no reason to produce anything but routine data. Astronomers see noise all the time, cosmic rays dust on the optics, irregularities in the software, but this one moved with intention. A subtle motion small enough to ignore, yet persistent enough to whisper. Look again. And from that whisper emerged the story of Through-Eye Atlas, the third confirmed interstellar visitor in human history, a wanderer older than our continents, older than our myths, older than anything we have words for. The first thing scientists noticed was its trajectory. It didn't belong to our sun. It was not looping, not curving, not performing the familiar elliptical dance of comets bound to this system. Instead, it carved a clean, decisive line through the solar neighbourhood, an unbound traveller passing by rather than returning home. Interstellar objects do wander through the void, flung from young planetary systems by gravitational tempests, but seldom do we catch one in the act of drifting past our star. And you listener seated here in the stillness of night are part of that unfolding cosmic moment. You're not lost in space, you're woven into it. Then came the chemistry. The Very Large Telescope detected nickel tetracarbonyl, a compound that does not form naturally in space. On Earth it appears only in industrial processes, in factories, laboratories-controlled chambers of human engineering. The object was releasing it at 4 grams per second without a trace of iron beside it. In astrophysics, nickel and iron are siblings. They emerge together from dying stars bonded like twins in the fires of supernovae. To find one without the other is to find a footprint without a foot, a flame without heat, an echo without voice. Instruments do not imagine things, they simply wait for us to accept what we struggle to understand. And then the orbit revealed something stranger still, a 0.2% chance that a foreign object would align so neatly with Earth's orbital plane. A 0.05% cumulative probability that it would pass Venus, Mars and Jupiter in such closely timed sequence. Each event rare, all of them together improbable. Not impossible, nature loves chaos, but it rarely arranges chaos this elegantly. Sometimes science calls this coincidence. Sometimes coincidence feels like choreography. Silence is the universe thinking. Avi Loeb, infamous and respected in equal measure for his insistence on questioning the comfortable assumptions of astronomy, rated 3-Eye Atlas a 5 to 6 on his artificiality scale, not as a declaration but as an acknowledgement of mystery. 7 independent anomalies, 7 threads tugging at the edge of what we think we know, not enough to claim the extraordinary, too many to dismiss. Then came the moment that unsettled even the skeptics. On October 29th, when the object reached its perihelion, its closest approach to the Sun, Earth sat directly opposite. For 3 crucial weeks, Through-Eye Atlas vanished behind solar glare, not dimmed, not partially obscured, hidden completely. It was as though the universe had drawn a curtain at the exact moment the object's structure should have been revealed, when the heat would peel back its surface, when its true composition might have spilled into view. What are the odds that such a rare visitor already wrapped in statistical improbabilities would reach its most revealing moment, precisely when no telescope on Earth could see it? 1 in 20, 1 in 30. Or something deeper, something that mathematics alone cannot capture, some quiet rhythm the universe keeps to itself. Some mysteries aren't meant to be solved, only observed. And now we approach December 15th, when 3-Eye Atlas will pass 170 million miles from Earth. Far enough to pose no threat. close enough to mark the nearest documented approach of an interstellar object in human history, most of the world will never know. They will wake, drink coffee, scroll their screens completely unaware that a wanderer from another star is slipping past silent as breath. You traveller, you are the exception. In observatories across the globe, scientists whisper about mass anomalies, improbable alignments, and a chemical fingerprint that refuses to fit any natural model. Some wonder if the object is simply too massive to exhibit the usual outgassing effects. If it barely shifts when the sun heats its surface, does that mean it might be hollow? Might we be seeing only the frost and dust that accumulated during millions of years of drifting through interstellar clouds? And if so, what lies beneath? It's all right to not understand. The universe has no obligation to explain itself cleanly. Some truths arrive slowly over decades, centuries. Some arrive incomplete. Some drift past us without ever shedding their silence. The real Sunday Atlas might be one of those truths, a reminder of our smallness, our curiosity, our quiet longing to make sense of things we were never meant to grasp in full. When the blackout ends, humanity will point its most powerful instruments toward the object. Hubble Webb adaptive optics telescopes from mountain tops and deserts, all capturing photons that left the object minutes ago, hours ago, lifetimes ago. They will analyse spectra, search for rotation, measure heat, reconstruct chemical signatures. But none of our instruments not yet can see inside it. We are limited to what the surface chooses to reveal. The rest remains hidden like a sealed letter floating across the ocean of space. December 15th will come and go. Perhaps the object is nothing but a comet from a colder system. Perhaps it's a probe disguised by time and dust. Perhaps it is something in between or something beyond our current vocabulary. But whatever it is, it moves with the calm confidence of something ancient, unbothered by our questions, continuing its long journey toward the darkness that awaits beyond our sun. Tonight the universe whispers again. Listen gently. Sleep, traveller. The cosmos will keep watch. Imagine again, traveller, that after the first shock of discovery settles, the astronomers do what they always do, they measure. Night after night they track the object's position against the slow drift of background stars. They refine its orbit, correct for noise, account for solar pressure, adjust for parallax. In the quiet hours before dawn they feed numbers into equations older than satellites, older than computers, older than the space age itself. And from those numbers comes a conclusion so heavy, so improbable, that even the most disciplined scientists hesitate before accepting it. 33 billion tons. That is the minimum mass of 3 Atlas. A number so large it almost doesn't feel real. A number that belongs more to mythology than to celestial mechanics. But the math is cold, impartial, unromantic. It tells us what is not what we wish to believe. When comets approach the sun, their ices vaporize, releasing jets that act like tiny rocket thrusters. This outgassing pushes them off course in subtle, measurable ways. Astronomers detect these gentle nudges as non-gravitational acceleration. It is one of the defining signatures of a natural comet. But 3T Atlas hardly moves at all. Its trajectory matches pure gravitational motion to astonishing precision. If the jets exist, and we know they do because multiple telescopes have directly measured gas streaming off the object, yet the object does not flinch, then the only explanation is simple and unsettling. It is too massive to be pushed. Like trying to shift an aircraft carrier by blowing gently on its hull. The force is real. The movement is not. And so, the scientists run the numbers again. They measure the gas production rate, about 150 kilograms per second, according to the James Webb Space Telescope. They compare this thrust to the actual trajectory, and they arrive at the same answer with the same finality, 33 billion tons, give or take. Traveller, imagine standing at the edge of the ocean watching a mountain float past you in silence. That is what we confront here, not a pebble from another star system, but something the size of a small terrestrial city, gliding on a path that brushes past 3 planets, as though threading a cosmic needle. Inside observatories, this mass estimate spreads like a rumour too heavy to ignore. Researchers sip cold coffee, reread the data, and feel the weight of the unknown settling gently on their shoulders. It does not scream, it does not frighten. It simply sits there, immovable, undeniable, like a distant truth waiting to be understood. You're not lost in space. You're witnessing its patience. The mass leads to another question. Why is this object so large? The previous two interstellar visitors, Oumuamua and Borisov, were small, modest fragments, consistent with natural debris ejected from young planetary systems. But Thrill Atlas dwarfs them by factors of thousands to hundreds of thousands. According to every model of how planetary systems form, big objects are rare. Small ones are plentiful. For every 10-kilometre object wandering through interstellar space, there should be hundreds of 1-kilometre fragments, thousands of 100-metre shards, millions of smaller pieces, yet we found one of the largest categories first. Some scientists call this the mass budget problem based on our models. Nature simply should not produce this many giant interstellar wanderers, not unless we are missing something fundamental about how debris populates the galaxy. But Traveller, there is another possibility, a softer, quieter one that some whisper but few dare to write in a paper. What if the object is not a solid chunk of rock and ice? What if its staggering mass does not come from bulk material at all? Imagine a hollow structure, a shell, a thin but strong framework designed to endure millions of years of drifting between stars. Humans do this instinctively. We build ships with empty holds, aircraft with hollow wings, satellites with internal cavities. Strength through geometry, not density. Lightness disguised by shape. A thin-walled sphere 10 kilometers across could weigh tens of billions of tons while remaining largely empty inside. Of course, this is not evidence, only a thought experiment, a way to explore the limits of what the data allows. The telescopes cannot see inside 3 Atlas. They only see what sunlight reveals, a surface coated in dust and ice, behaving like the outer skin of a comet. Frost on a windshield, snow on an old monument. The disguise formed naturally by time, not necessarily by intent. Somewhere beyond our reach, something ancient still moves. And here is where perspective becomes both humbling and peaceful. Whether natural or not, whether hollow or solid, whether it carries secrets or nothing but frozen gas, the object moves through our solar system with serene indifference. It does not hurry. It does not threaten. It simply exists, and our role as observers perched on a small blue world is to watch, to study, to wonder. Tonight, the universe whispers again. You may feel the weight of questions. What if it is artificial? What if it is natural, but from a place unlike any we've imagined? What if its mass is a clue? What if it is only a coincidence? It's all right to not understand. The cosmos is full of enormous silent teachers, and most of them never explain themselves. They pass by, once leaving only a trail of data, a handful of anomalies, and a sense of awe. 3I Atlas is no different. It may never reveal its purpose, its past, or its true composition, but it invites us to look up, to think deeper, to rest in the presence of something larger than our certainty. Tonight, Traveller, let the thought settle gently. Some mysteries aren't problems to solve. They are places to sit and breathe. Sleep now, the cosmos will keep watch. Imagine, Traveller, that after the massive 3I Atlas settled like a quiet weight in the minds of astronomers, the next mystery began to take shape. Not in the chemistry, not in the brightness, not even in the mass, but in the path the object followed through our solar system. Because every object from another star should arrive at a random angle, wandering in from above or below our orbital plane as if tossed into our neighbourhood by the chaotic life of distant suns. But 3I Atlas behaves differently. It doesn't come in steeply, nor sideways, nor at a slanted pitch as interstellar debris normally does. Instead, it glides almost perfectly along the same thin disk in which Earth and the other planets orbit. A plane so precise that astronomers call it the ecliptic, the fossilized memory of how our solar system formed from a swirling disk of dust and gas 4.5 billion years ago. Interstellar visitors should ignore this plane entirely. They should approach like strangers entering a room with no knowledge of where the furniture sits. But 3I Atlas enters as though aware of the layout. Its inclination is only 5 degrees off a gentle tilt rather than the wild angle expected from a foreign traveller. Scientists calculate the odds about 1 in 500 for such an alignment to occur by chance. Not impossible, but quietly unlikely. One anomaly is coincidence. too becomes a curiosity. But then the object continues along its path in a way that pulls the minds of observers into deeper contemplation. Because Traveller, after sliding onto the ecliptic three-eye atlas, does something stranger. It passes remarkably close to 3 different planets, Venus, Mars and Jupiter, each at a moment when those planets happen to be nearby. Not close in the sense of danger, but close in the sense of geometry, as though the object is brushing its fingertips along the orbits of worlds like a hand gliding along the spines of books in a quiet library. Mars on October 3rd, Venus on November 3rd, Earth on December 15th, Jupiter in March. Different planets, different distances, different orbital speeds. Yet the timing aligns. Scientists calculate the combined probability 1 in 20,000. The room goes quiet. Not because anyone believes in an intention, but because the numbers lean into a region where nature feels almost too elegant. It is the kind of coincidence that makes even the most grounded researcher pause, lean back and whisper to themselves, "What are the odds? Traveller." I want you to picture the solar system not as a diagram in a textbook, but as a vast, delicate clock. Worlds orbit like gears, turning at their own speeds, each one obeying its own rhythm. Mars completes a circuit every 687 days, Venus every 225, Jupiter every 12 years. For an object from beyond the Sun to pass near all 3 during a single visit requires an alignment that feels improbably graceful. A harmony of motion across millions of miles, the orbital equivalent of rolling a pair of dice and watching them land on double sixes again and again, until even the most patient gambler begins to examine the dice more closely. But the universe does not cheat. It simply arranges itself with a subtlety that often eludes us. As Three-Eye Atlas approached Mars, NASA directed the HiRISE camera aboard the Mars Reconnaissance Orbiter to attempt a rare observation, a photograph of an interstellar object taken from another planet. HiRISE was built to capture the rugged rocks and dust of the Martian surface, but for that one moment it pointed outward into the dark. The resulting image, far from spectacular, still offered a quiet truth, a faint elongated glow, a nucleus barely large enough to register a cloud of dust shifting gently in solar wind. Nothing dramatic, nothing geometric, nothing clearly artificial, and yet something in the brightness profile seems subtly off-centre, slightly displaced from where models predicted the densest part of the coma should be. Not wrong, just different. One more whisper added to the chorus of small persistent curiosities surrounding this visitor. But Traveller, that is the nature of astronomy. Most of what we learn comes not from dramatic revelations, but from the soft edges of data, the faint deviations, the gentle asymmetries, the patterns that appear only when viewed from just the right angle. Science, too, has its own form of meditation waiting patiently for meaning to emerge. Now imagine the ecliptic plane as a quiet river. The planets drift along it in serene procession like lanterns floating downstream. And now, imagine Three-Eye Atlas slipping onto that river from a distant shore, aligning itself with the flow rather than cutting across it. Why? That is the question that lingers. Some say coincidence, some say selection bias, some say we are reading too much into the dance of celestial objects, and some few, careful not to speak too loudly, wonder whether the object simply moves this way, because the ecliptic is convenient not for intention but for physics. A path of least resistance, a natural corridor through gravitational stability, a cosmic highway on which any object passing through would naturally find itself drifting. Even the most skeptical scientists entertain the possibility that this is all natural, very likely so. The simplest explanations often survive the longest. But the human mind, a mind built to detect patterns, to notice anomalies, to seek meaning, cannot help but feel the quiet tug of mystery. What if there is something more beneath these coincidences? Not something frightening, not something grandiose, but simply something we do not yet understand. A principle embedded in celestial mechanics that we have not uncovered. A bias in our observation methods. Or perhaps a subtle gravitational shepherding effect from the planets themselves, nudging Three-Eye Atlas into a path that looks designed but is merely the result of long quiet interactions across millions of miles. You're not lost in space, Traveller. You're drifting alongside a question the universe has placed gently in your path. As December 15th approaches, telescopes will be pointed at the region of sky, where 3i Atlas drifts like a dim lantern at the edge of the solar wind. Observers will track every shift in its orbit, searching for deviations too large to be natural or too subtle to be noise. They will measure whether sunlight alone can account for its motion. They will look for jets of gas emerging from unexpected regions. They will watch for any hint of acceleration or braking that might betray an unseen force. But the truth traveller, the quiet, humbling truth, is that the universe often refuses to make itself simple for us. We may collect all the data in December, we may refine every orbit measure, every wavelength, and still be left with a single gentle realization that this object, whether natural or not, has chosen a path that brushes the edges of our understanding. Tonight the universe whispers again. Let the sounds settle. Let the questions drift. Some mysteries aren't meant to be solved. Some are meant to accompany us like constellations, distant, patient, comforting in their silence. Imagine, traveller, that the universe sometimes turns its face away at the exact moment we lean forward to see it more clearly. This is what happened on October 29th, the day 3i Atlas reached perihelion, its closest point to the Sun, the moment when its surface should have erupted in thermal revelation. For any ordinary comet, this is when the Sun becomes a sculptor, carving away layers of ice, exposing the mineral heart beneath, altering the shape, the spin, the chemistry. It is the moment when a comet tells the truth about itself. Yet on that day, Earth stood in the wrong place. Not almost wrong, not inconveniently wrong, perfectly, precisely, completely wrong. As the object skimmed behind the Sun, our planet drifted into alignment on the opposite side, placing 3i Atlas in full solar conjunction, hidden behind a wall of light so bright that every telescope on Earth, and even most orbiting instruments, were effectively blinded. It was as though the Sun pressed a finger to our lips and whispered, "Not yet." 3 weeks passed, days sliding silently into one another as the object vanished entirely from our view. It is hard to describe the weight of those 3 weeks. Scientists don't often use words like anticipation or longing, but that is what it felt like. A collective breath held across control rooms, observatories and quiet offices, lit only by the glow of data monitors. Because perihelion is the one moment when comets, natural or not, can no longer hide. The heat forces them to reveal their core. A natural comet might fragment, break, spin erratically, shear off pieces of itself. Its tail brightens, its chemistry changes, its coma erupts, and if the object were anything other than natural, it too might leave a signature, an impulse, a shift, a deviation not accounted for by solar forces. But we saw none of it, not because nothing happened, but because the Sun made sure we could not look. Traveller, imagine watching a key slide into a locked door, knowing it will turn, knowing the mechanism will activate, but being forced to look away just as it moves. That is what the blackout felt like. A missing page from a story that refuses to reveal its ending. Astronomers ran simulations, thousands of them, modelling how natural comets behave at perihelion, especially those rich in carbon dioxide like 3i Atlas. They expected sunlight to vaporise the ices in bursts to push the object slightly off course, to create measurable non-gravitational acceleration. But the object's motion before and after perihelion would have to be compared, and that could not happen while it hid behind the Sun. Somewhere in those calculations, a quiet question began to emerge. What if perihelion is not just a moment of exposure? What if it is a moment of opportunity? You may not know this, traveller, but spacecraft hours use periapsis manoeuvres as well. When a probe swings near a planet or star, firing its engines right at the moment of maximum velocity, creates the most efficient change in course. It is the principle behind the Oberth effect burn when you're deep in the gravity, well, when your speed is highest and the same amount of thrust yields more change in orbital energy. It is how we send probes deeper into the solar system, how we accelerate or decelerate or shift trajectories with elegance and minimal fuel. And if an object of unknown origin wanted to change course quietly, discreetly, imperceptibly from a distance, perihelion would be the perfect time, especially if it occurred during the one period when every observing eye on Earth was closed. This does not mean the object is artificial. It does not imply intent. But the coincidence, the alignment of perihelion, the geometry of Earth's position, The duration of the blackout lingers like a thin mist over the data. Not accusatory, not alarming, just present. A quiet anomaly in a universe full of them. When November came and 3i Atlas began to emerge from behind the sun, telescopes awakened with something close to reverence. We gathered photons like monks collecting fragments of scripture. And what we saw first was something almost comforting. The object was still intact. No catastrophic breakup, no violent shedding of material, no dramatic increase in brightness. Just a dim visitor drifting outward again, silent as before. But science is not satisfied with first impressions. The true test lies in the trajectory. Did it shift? Did perihelion nudge it? Did the sun carve away just enough material to alter its path? Or did something else happen? Something subtle, hidden beneath thresholds of detection? Traveller, this is where astronomy becomes a kind of meditation. You must be comfortable with delay, with uncertainty, with silence. To determine the new orbit, scientists need time. Weeks, months. They need multiple observations from multiple vantage points at different distances to reconstruct the arc of motion with precision. The data trickles in like water drops echoing in a cavern. Slow, methodical, necessary. And so we wait. For some, this waiting is calm. For others, it feels like standing on the edge of a dark forest listening for a sound you're not sure you want to hear. Theoretical models multiply. Conversations behind closed doors grow longer, quieter. Some astrophysicists shrug, it will be natural. It always is. Others murmur, probability has teeth. A few more poetic than their colleagues simply say, I want to know. You are not alone in wanting to know. In the early days of November, as the object's faint glow reappeared on sensitive detectors, there was a shared moment. A fragile one when scientists stared at the first post-perihelion coordinates and realised they meant almost nothing yet. The object was too distant, too faint, too newly emerged. But that moment felt like the universe cracking its door open an inch, letting a sliver of truth spill through. Not enough to illuminate, just enough to remind us we are small. The days that followed were filled with the soft, relentless hum of observation, ground-based telescopes peering through atmospheric turbulent space-based observatories, filtering out solar radiation deep field instruments, extracting faint signals from noise. Every night, more dots appeared, each one a position in the sky, marking where 3i Atlas had been. A breadcrumb trail written in starlight, and slowly, gently patterns began to form. Perhaps the trajectory is unchanged, following the dictates of gravity alone. Perhaps the sun's heat altered its coma, but not its path. Perhaps perihelion was uneventful, unremarkable, ordinary, or perhaps not. This is the nature of astronomy, traveller. It teaches patience. It teaches humility. It teaches that certainty is a gift rarely granted. And it teaches that sometimes the most profound truths are found not in what we see, but in what we are unable to see. Tonight, the blackout window still lingers in the scientific imagination, a blank page, a hollow chamber in the middle of the story. Whatever happened there belongs to the object alone. It carries the silence with it, now drifting outward through sunlight, different to our curiosity. Let that silence settle into you. Let it remind you that not every mystery is meant to bend to our understanding. Some remain simply themselves, unexplained, unhurried, unbroken. Rest, traveller. The cosmos will keep watch. Imagine, traveller, a telescope floating above the blur of Earth's atmosphere, a silent guardian orbiting in the cold, collecting starlight that has travelled for millions of years. The Hubble Space Telescope is not young anymore. It groans in its joints like an old astronomer who has spent too many nights awake. And yet when 3 Atlas drifted into view on July 21st, Hubble turned its glass eye toward the visitor with the same steady devotion it has given to galaxies, nebulae, and worlds far stranger and more distant. The image it captured did not shout its secrets, it whispered them. A soft teardrop-shaped glow wrapped around an elongated nucleus like a candle flame pressed gently in the palm of a hand. Dust and gas drifted outward from its surface, scattering sunlight into a faint halo. and in that halo was something unexpected, a faint extension pointing toward the sun, not away from it. In the quiet control rooms where astronomers studied the data, the first reaction was confusion, then suspicion, then the sober process of ruling out what such a structure could be. Comet tails do not point sunward. Solar radiation pressure pushes dust and gas away from the sun, always, without exception. And yet here was 3i Atlas displaying a faint suggestion, a filament of light leaning in the wrong direction. A contradiction written in photons. The explanations came quickly, and most were reasonable. Motion blur can mimic structure. The comet was moving fast relative to the background stars. Hubble's long exposures designed to coax faint details from darkness can stretch bright regions into streaks. When a nucleus shifts even slightly during an exposure, the brightening can smear forward, creating an illusion of a tail where none exists. This happens often enough that scientists recognize it like a familiar ghost, and yet Traveller this time the ghost felt a little too well formed. For weeks astronomers debated it. Some dismissed it immediately as an artifact, others hesitated. The forward-facing smear was subtle but persistent. It didn't quite behave like typical motion blur. It looked almost like an extension, like a structure or density variation within the coma that moved in a way dust shouldn't. But science is not built on feelings, it is built on data. And the data was not strong enough to support a claim of anomaly. So the phenomenon was noted catalogued and placed gently in the drawer of interesting but not definitive observations. Still, the universe was not finished. As August grew long and the object approached the inner orbit of Mars, the Gemini South Telescope in Chile captured a new set of images, sharper, steadier, unmarred by the distortions of motion blur. And this time, the specimen of the light behaved more like a normal comet. Clear sunward trailing tail emerged. Dust flowed outward exactly as physics predicts. The object looked at last like it belonged to the natural order. At first, scientists felt relief. An unusual comet is one thing, an impossible comet is another. But the timing of the transformation raised a quiet question among those who had watched closely. Why did the comet look ambiguous for 6 weeks, displaying odd brightness behaviour and strange forward structures only to become conventionally comet-like just as it neared Mars? Why did it shift from puzzling to ordinary, precisely when higher exposure, higher resolution images were taken? There are natural explanations, and many of them plausible. Ice buried beneath the surface may have begun to sublimate only at closer distances to the Sun. Early gas jets may have been directional or intermittent. The geometry of the viewing angle may have obscured real structures until the object rotated into a more revealing orientation. Comets are unpredictable creatures shaped by irregular surfaces, ancient fractures, and layers of material older than the planets themselves. They seldom behave in ways that are perfectly neat or predictable. But there is also the stranger possibility, whispered like a superstition in academic halls, that a technological object masked in layers of interstellar frost might show changing visual features as new areas heat and shed dust, gradually revealing the behaviour of whatever lies beneath. Not necessarily artificial, not necessarily intentional, just not easily explained. You're not lost in space, traveller. You're drifting through thought, through questions, through the soft fog of scientific uncertainty. It is important to understand that no observation from Hubble or Gemini proves anything unnatural. The images do not reveal metal struts or geometric hulls or luminous engines. They reveal dust and gas and light things, familiar things expected. But the pattern of behaviour, the sequence of visual anomalies followed by sudden normalisation, does not fit comfortably into the standard models. Imagine looking at a stranger and seeing for a fleeting moment an expression that doesn't match the words they speak. And before you can place it, before you can understand the emotion behind it, the face relaxes and goes still. You are left unsure whether you imagined it or whether something deeper stirred beneath the surface. That is how astronomers speak of 3 Atla when they let their guard down. When researchers compared the July Hubble images to the August Gemini South frames, the differences were stark. What looked like a forward anomaly in July vanished. The tail became clean, directional, familiar. The coma settled into a shape consistent with increasing solar heating. If one were to view only the later data, the object would appear wholly unremarkable, a comet like many others, drifting along a path carved by sunlight and ice. But science is a story told across time, not a single frame, and the early images remained. They sit in archives, quietly resisting neat interpretation, a reminder that the universe often introduces itself with a riddle before offering a resolution. Even now, no one agrees on the significance of the forward structure. Some insist it was an artifact. Some suspect an unusual jet active only during the early stages of heating. Some think we simply looked at it from an unfortunate angle. A few do not speculate at all, preferring humility to unwarranted confidence. Silence is the universe thinking. What Hubble saw in July and what Gemini South saw in August are two chapters of a story still being written. One faint, ambiguous, suggestive. The other clearer, more predictable, more aligned with what we understand. Between the two lies a transition, one that tells us the object is not static, not simple, not easily pigeonholed. Traveller, let your mind drift gently into that uncertainty. Let it rest in the knowledge that not every question will resolve neatly, that not every anomaly must be a message, that not every mystery requires an answer. What matters is that we are witnessing something rare, a visitor from beyond the cradle of our sun, carrying with it the textures of another cosmic history. And as it journeys outward, becoming fainter each day, it leaves behind not just images, not just data, but a soft feeling, like the echo of a dream. A reminder that even the oldest instruments like Hubble, and the newest like Gemini South, can only reveal hints of the truth, never the whole of it. Tonight, traveller, the comet's light lingers in your thoughts. Let it fade slowly, gently, like dust drifting in sunlight. Rest. The cosmos will keep watch. Listen. Traveller chemistry is the universe whispering through light. Every atom carries a signature, a soft glowing fingerprint that tells us where it has been, what it has touched, and which fires forged it. When astronomers look at a comet, they are not truly looking at rock or ice. They are listening to faint ancient syllables of light scattered by molecules older than our world. And when they listened to Thri Atlas, something in that whisper didn't sound quite right. It began quietly, as anomalies often do. In late August, the Very Large Telescope in Chile detected the spectral fingerprints of atomic nickel-thin bright lines that stand out like silver threads against the darkness. Nickel vapor escaping into the coma at a rate of roughly 4.6 grams per second. That alone is unusual but not unheard of. Several comets in our own solar system contain nickel-bearing minerals that release vapor when heated. What disturbed the researchers was not the nickel itself, but what wasn't there. The iron was missing. Nickel and iron are born together, fused in the collapsing hearts of ancient supernovae. They travel through space, bound by shared origins, settling into planets and asteroids in roughly equal proportions. Where there is nickel, there is almost always iron, its heavier, more common sibling. But in 3I Atlas, the iron line was faint to the point of invisibility. It should have been there. The physics demanded it. The chemistry demanded it. The universe demanded it. And yet, silence. When the spectra were first analysed, the reaction in the scientific community was a quiet pause, a raised eyebrow, a long exhale. Comets are chemical mosaics, yes, but they rarely rewrite the rule book. Was the iron locked in compounds too stubborn to break apart? Was it buried deeper beneath the surface where sunlight could not reach? Was the temperature too low for iron vapour, but somehow high enough for nickel? Were the instruments missing something subtle? Some hidden variation in the coma? Each explanation was possible, none felt fully satisfying. But the universe seldom gives us perfect clarity. It gives us clues scattered like crumbs across the night sky, and asks us to follow them with humility. So the iron mystery was recorded, noted as unusual but not unprecedented, and the researchers waited for the next whisper. It came from the James Webb Space Telescope. Its infrared instruments, peerless in sensitivity, measured the gases streaming from 3I Atlas. And what they found deepened the puzzle. Not only was the object releasing nickel-rich vapour, but its emissions were dominated by carbon dioxide at levels nearly 8 times higher than water. This is not how comets behave. In nearly every frozen wanderer we've studied, water is the dominant volatile, the first to sublimate as sunlight warms the nucleus. Water drives the comet's activity, pushes dust outward, forms the coma, creates the tail. But 3C Atlas seemed to reverse the hierarchy. Carbon dioxide led, water followed. Some theorized that the object formed in an extremely cold region of its parent star system, far from its sun, so far that water remained buried beneath layers of carbon dioxide frost for billions of years. Others suggested that the comet was ancient in a deeper sense forged, when the Milky Way was younger, chemically different, richer in strange ices and depleted in familiar molecules. Perhaps some said the carbon dioxide came not from birth but from travel. A long voyage through interstellar clouds could coat a rocky body in a layer of exotic frost, creating a surface chemistry unlike anything in our solar system. These were not explanations of certainty, traveller. They were gently offered possibilities, attempts to make peace with the unknown, yet the anomalies continued. Astronomers studying the spectral fingerprints of 3I Atlas noted that it was carbon chain depleted, unusually lacking in the 2 and 3 carbon molecules that typically paint comets with a distinct green glow. Such molecules light up the coma when sunlight breaks them apart, giving many comets a ghostly emerald halo. And yet during a total lunar eclipse in early September, when the sky was black enough to amplify the faintest shades of light, astrophotographers captured the visitor with a distinct green hue. Green where there should be none, colour where the chemistry said there should be silence. The explanation might be simple. Cyanide, another molecule detected by the Very Large Telescope, glows green when excited by ultraviolet radiation, or perhaps deeper layers of buried volatiles were only then being exposed. Or perhaps chemical processes we barely understand were taking place in the vacuum, driven by conditions that occur only in comets, whose origins lie between the stars. But again, traveller, each explanation was a possibility, not a conclusion. None contradicted the laws of chemistry, but none aligned comfortably with what we expect either. It is the pattern that unnerves scientists the most, not the anomalies themselves, but the way they assemble. Nickel without iron, carbon dioxide without water dominance, green glow without the usual carbon chains. Activity that turns conventional only after weeks of confusion. Behaviour that evolves in ways natural models strain to explain. Each strangeness has a natural explanation somewhere in the library of cosmic processes, but taken together they form what one researcher called persistent quiet oddity. A strangeness that accumulates like dust in an old room, too subtle to prove anything, too present to ignore. And still all the while, 3I Atlas drifts forward through space, ancient and indifferent, carrying its chemistry like a sealed letter. Perhaps the message inside is simple, that the universe is wider in its creativity than we give it credit for. Or perhaps, as some whisper in private, there is more beneath the surface literally and figuratively than telescopes can reveal. Imagine a technological object travelling through interstellar night for 1 million years. Imagine layers of dust and ice collected from nebulae accreting like sediment. Imagine each pass near a star heating the shell just enough to release certain molecules but never enough to reveal what lies beneath. All of its emissions would appear natural. All of its chemistry would seem comet-like. It would whisper in the same spectral language we have learned to interpret. Light cannot tell us everything. It can only reflect the surface. Traveller, it's all right to not understand. Science is not the art of certainty. It is the art of listening carefully to what the cosmos chooses to reveal. And tonight, as 3I Atlas continues its slow passage toward December, the chemistry still doesn't quite fit, but the universe is patient. It has waited billions of years to show us this visitor. It can wait a little longer for us to understand. Rest now. Let the unanswered questions drift like vapour in the cold. Some mysteries are not meant to be solved, only observed. December approaches quietly, traveller, the way dusk approaches a still lake. Or winter approaches the waiting branches of a sleeping forest. It is a slow, inevitable turning of time, and somewhere high above us beyond cloud and cold, and the thin blue breath of Earth's atmosphere, an interstellar visitor glides toward the moment of its closest encounter with our world. Not close enough to fear, not close enough to see with your eyes, but close in the mathematical sense, 1.8 astronomical units, a distance that is nothing to the universe and everything to us, because it represents the nearest humanity has ever knowingly been to a traveller from another star. This December, every major observatory prepares with a kind of reverence. In Chile, domes open like the petals of metal flowers. In Hawaii, telescopes wait above the clouds, sharpened and poised. Even Hubble and James Webb Veteran and Newborn will tilt their instruments toward a faint moving dot in Virgo. The sight will not be spectacular. It will not glow brightly or carve fire across the sky. It will appear only as a dim smear of reflected sunlight lost in the background of stars. But the scientists watching know the importance of this moment. For months they have waited, calibrating instruments, refining predictions, calculating the best windows to observe. December is not just a date on a calendar. It is the final doorway into the small sliver of time when Thurbias is close enough, bright enough, cooperative enough to reveal even a fraction of its truth. And yet, traveller, even with all our instruments open, even with our attention sharpened, we will still not know everything. Light tells us only about surfaces, only about the outer skin of an object born in another star's forgotten embrace. December will give us colours, temperatures, rotation, patterns, gas ratios, tail, geometry, and thermal imprints, but not motives, not origins, not the mystery at the object's core. That is the eternal frustration of astronomy. We learn so much, and yet every answer reveals new questions curled beneath it like roots under frost. The universe allows us to touch only its shadow. Still, December matters. It matters because the data gathered in these 10 days will define how we understand interstellar visitors for decades. If the object behaves like a comet rotating irregularly, shedding gas in predictable waves, cooling as it retreats, then the anomaly dissolves into the familiar. But if the strangeness continues, if the trajectory deviates subtly, if the thermal signature contradicts the chemistry, if the brightness curve hints at geometry beneath the ice, then we enter a new realm of interpretation. Not science fiction, but scientific humility, the awareness that our models are incomplete, that our assumptions may be too narrow, that nature may be richer than we imagined. Imagine yourself standing beside a radio telescope at night. The air is cold, the dish enormous above you, listening to the cosmos at frequencies the human ear cannot comprehend. A soft hiss fills the control room, a tapestry of noise woven from the Big Bang solar wind and ancient signals travelling across billions of miles. Somewhere in that static, if anything exists at all, could be the faintest whisper of intent. If 3 Atlas were artificial, and we must always say if with caution it might speak not in light but in narrowband pulses, mathematical rhythms too precise for natural processes. But so far the sky is quiet. Silence is data to traveller. Silence is the universe thinking. Optical telescopes will watch for rotation. Natural objects tumble chaotically, shaped by collisions and uneven mass distribution. Artificial ones, if such things exist, might rotate with purpose, holding their orientation with deliberate steadiness. And so, astronomers will study the brightness variations, searching for patterns in the flicker of reflected sunlight. They will look for the way dust streams off the surface. They will examine how the coma expands, how the tail bends, how the thermal footprint spreads across the nucleus. Every tiny detail becomes a letter in a much larger alphabet of cosmic behaviour. The truth, traveller, is that December will not bring revelation. It will bring refinement. It will shape the questions more sharply. It will illuminate the edges of the unknown. It will help us understand what 3i Atlas is, not even if it cannot fully tell us what it is. But that is the nature of cosmic inquiry. We learn by subtraction as much as by discovery. And when the object passes closest to Earth on December 15th, when it reaches that quiet point in space at 1422 UTC, crossing an invisible line of proximity that will never occur again in human history, nothing dramatic will happen. No sound, no flash, no omen in the sky. Just a visitor moving onward, outward, back into the vast dark. Most of humanity will never know anything happened. They will walk through their day unaware that something timeless and ancient slid by in silence. But you, traveller, you will know. You will know that an object older than our world passed quietly near us, carrying secrets it will never fully reveal. You will know that our telescopes reach toward it like hands reaching in sleep, hopeful, uncertain yearning. You will know that this December Earth turned its face toward a mystery and listened with every instrument it had. Let that knowledge settle gently within you. Let it be a reminder that you are part of a universe far larger than fear, far older than doubt, far deeper than any question a single mind could hold. Let it remind you that cosmic mystery is not a threat, but an invitation to wonder, to imagine, to rest inside the unknown without demanding answers. Tonight the universe whispers again. And December moves closer quietly as all important things do. Rest now. The cosmos will keep its watch. Traveller, let your thoughts drift for a moment to a cold world far from home. A world of red dust, thin skies, silent plains. Mars has always been a kind of mirror for our curiosity, a place where we project questions about life, loneliness, possibility. And on October 3rd, 2025, while most of humanity carried on with ordinary routines, something extraordinary occurred in that distant sky. Far above its ochre deserts, the Mars Reconnaissance Orbiter, an old and loyal machine, turned its gaze away from the planet it has studied for nearly 20 years and aimed at 3 Iatelis. It was a strange maneuver, traveller. High-rise. The camera aboard the orbiter was never built for this. Its purpose is to photograph the Martian surface with such precision that it can see individual boulders, the scars of ancient rivers, the faint traces of dust devils sweeping the plains. It was not meant to study faint visitors tens of millions of kilometres away. And yet, because of geometry, because of timing, Mars offered an angle that Earth could not. A chance to see the nucleus of the interstellar traveller more directly than any ground-based telescope could manage. When the images arrived, they were not sharp or crisp. They were faint shadows framed in haze pushed to the very limits of what an instrument could detect. But they were real, and in those soft blurred shapes something began to emerge, not a revelation, but a texture, a hint, a whisper. The nucleus appeared elongated, not spherical. A faint brightness stretched along one axis as though the object itself were a shard rather than a pebble. The coma drifted around it in a diffuse glow, like the breath of something ancient exhaled slowly into space. But it was not the nucleus that stirred the astronomer's attention. It was the location of the brightest light within the coma. The brightness wasn't centered. It was shifted by tens of kilometers toward the sun. This small offset created a ripple of quiet curiosity among those studying the images. Comets usually display the densest region of their coma directly around the nucleus. Material flows outward evenly before sunlight and solar winds sculpt it. But 3I Atlas seemed to glow more on one side than the other, almost as if the centre of activity, the heart of evaporation, the true locus of heat, was not aligned with the object's body. There were natural explanations. There always are. Perhaps the sun-facing side was simply more active, a jet-releasing gas in a concentrated plume, pushing dust outward like a breath. Perhaps rotation carried active regions into the light at just the right moment. Perhaps fragments trailed nearby, creating uneven densities. Comets are chaotic, uneven things. They behave like relics, not machines. And yet some scientists noted quietly, privately, that such an offset could also occur if the nucleus were not solid at all, but hollow if the true structural mass sat deeper inside, shielded by an outer shell of collected ice and dust. In such a scenario, the surface material could heat unevenly, depending on thickness, density, or composition. Sunlight would not strike a uniform object, but rather a layered one, a shell that might sublimate irregularly, creating brightness patterns decoupled from the structural core. This idea was not presented as a conclusion. No one stood before a camera and declared artificiality. Science does not leap, it steps. But the thought lingered like a faint afterimage when you close your eyes. The asymmetry itself was not shocking. Comets do strange things. But what made it linger in the minds of researchers was how perfectly it fit into an ever-growing pattern. A pattern not of proof, but of persistent peculiarity. The Mars images were archived and NASA released a measured statement. No features inconsistent with a natural comet. This was true, and yet not the entire truth. For while nothing in the images demanded an extraordinary explanation, nothing dismissed one entirely either. The offset brightness was small, subtle, difficult to confirm, but it was there, captured in several frames unchanged across multiple processing techniques. It resisted perfect explanation even as it allowed multiple plausible ones. Imagine Traveller holding a feather that feels just slightly heavier than it should. Not enough to call it strange, but enough to make you tilt your head and wonder. That is what the Mars images were, a feather with an unexpected weight. As astronomers reviewed the data, they spoke softly in conference calls and private forums. Some suggested fragmentation events. Some pointed to thermal lag, the delay between sunlight and sublimation. Others considered complex rotation patterns. But a few raised a possibility more delicate, more fragile, that perhaps the nucleus we see is only the shell and the object we are studying is shaped not by randomness but by design. Yet even they spoke with restraint. To claim without certainty would be irresponsible. To speculate beyond data would be unscientific. And so the idea was placed gently alongside all the others, neither embraced nor rejected, simply acknowledged as one of many possibilities possible, but improbable, conceivable but unproven. There is something deeply human about that hesitation, Traveller. We long for certainty, yet the universe seldom offers it. Meanwhile, the object continued drifting. Mars receded behind it. The images were catalogued. The data was assigned to teams. The anomaly faded into the flow of daily work, but it did not disappear. As new measurements came in chemistry, trajectory, tail structure, the offset in the Mars images became part of a greater mosaic. A mosaic in which every tile was ordinary on its own, and yet arranged into a picture that felt subtly, persistently askew. And still, 3i Atlas said nothing. No signals, no flares, no breaks in rotation, just motion, just silence. Somewhere within that silence the universe thinks. Astronomers know how rare it is to image the nucleus of an interstellar object. Until now, it had happened only once when Oumuamua raced past Earth, before anyone realized what it was. But that object was too small, too faint, too fast. Its true shape remains a mystery, even now a shard of speculation drifting in mathematical space. 3i Atlas is different. Larger, brighter, slower, and caught at the right angle from a world not our own. The Mars images will be studied for years, not because they prove anything, but because they offer the kind of faint, ambiguous hints that astronomers rarely ignore. Science advances not only through breakthroughs, but through curiosities, tiny details that do not fit neatly into any existing drawer. This is how new theories begin, not with certainty, but with discomfort. As you listen now, Traveller, let your thoughts drift gently around that idea. Let yourself float with the object for a moment as if you were a small piece of dust carried along in its coma. Drift around it. Watch the sunlight hit one side more brightly. Notice the asymmetry. Feel the imbalance. Not threatening, just strange. Quietly strange. Somewhere within this silence, the universe invites you not to fear, but to wonder. And in that wonder, allow yourself to rest. For tonight, the faint images from Mars remind us that even the closest looks can reveal only the surface. The rest is hidden in shadow, waiting for patience, waiting for time, waiting for minds willing to sit gently with what cannot yet be understood. Sleep now, Traveller. The cosmos is still watching, and it keeps its secrets softly. Traveller, imagine a field of radio dishes spread across quiet valleys and mountain ranges, each one shaped like a pale, listening ear tilted toward the deep night. These instruments do not see the universe, they hear it. They drink the invisible waves that ripple across space, whispers from quasars, sighs of collapsing stars, the leftover breath of the Big Bang itself. And during the months when 3i Atlas slipped silently into our solar system, some of these giant ears turned, however briefly, toward the visitor. What they found was nothing. Not nothing in the empty sense, not a void, not an absence, but the kind of nothing that carries texture. A nothing full of hiss and cosmic static, like the soft roar of wind across an endless desert. A nothing that feels less like silence and more like distance. A nothing that says only the universe is wide, and this visitor is quiet. This is not unusual. Natural objects do not speak. Comets do not broadcast. Asteroids do not send narrow-band pulses toward distant civilizations. Silence is the default state of matter drifting through space. And yet, traveller in astronomy, silence can be as intriguing as sound. Shortly after the discovery of Three-Eye Atlas, several researchers proposed that the Breakthrough Listen project, one of Earth's most sophisticated SETI programs, allocate some listening time to the object. The logic was simple, not speculative. If aliens ever built probes, even long-lived autonomous ones, they might communicate the same way our own spacecraft do by radio. And if they did their transmissions, even faint, even ancient might still be detectable. A single narrow-band spike in radio, frequencies the kind nature never produces, would change everything. But Breakthrough Listen gave no immediate confirmation of plans. Telescope time is limited. Observatories operate on strict competitive schedules. Many researchers consider artificial origin hypotheses too improbable to merit major resource allocation. In the hierarchy of scientific priorities, listening to a quiet comet-like traveller may have seemed indulgent, even wasteful. So days passed, then weeks, then months, and through that entire span no signal was announced. But silence itself has layers. It is possible that observations were never performed. It is possible they were performed but yielded nothing unusual. It is possible the data is still being analysed carefully past for faint patterns. It is possible something anomalous appeared but required verification too delicate to rush. Radio silence is not a statement. It is an unresolved equation. Consider how we listen for artificial signals. Human technology searches for narrowband tones, repeating sequences, structured bursts. But what if an advanced probe used a method we've never imagined? Quantum communication, neutrino pulses, polarized beams tuned to alien physics. What if it transmitted only intermittently, or only toward its origin star, or only during certain phases of rotation? Or perhaps, what if it was never transmitting at all? Many spacecraft, even ours, go quiet between missions. Some sleep for decades. Some wait for commands that never come. Some drift as silent monuments to lost civilizations. If Three-Eye Atlas were artificial, and this is only an exercise of imagination, traveller not a claim, then its silence might not be ominous. It might simply be dormant, or cautious, or indifferent to our presence. But the more likely explanation is simpler. It is natural, and natural objects do not call home. Yet the absence of structured signals remains important in another way, not because it hints at alien intelligence, but because it highlights a strange cultural truth about astronomy. We are willing to listen for messages from distant stars, but rarely for messages from things that wander into our own neighbourhood. We scan suns dozens of light years away, hoping for artificial patterns in their radio noise, while the interstellar objects that drift directly through our solar system, the rarest visitors in the universe, pass by, mostly without dedicated monitoring. Traveller, sometimes humanity forgets that the frontier is not always distant. Sometimes it is passing quietly overhead. Radio telescopes continue to listen to the cosmos in their usual cadence, mapping fast radio bursts, timing pulses, measuring solar outflow, all while Three-Eye Atlas slipped by in silence. And for astronomers who believe in thoroughness, this felt like a missed opportunity. Not a tragedy, not a scientific failure, just an absence that lingers. Because radio silence can tell us two things at once. Either there is nothing there or there is something there, but it chooses not to speak in ways we understand. And both possibilities are humbling. In SETI, the absence of evidence is not evidence of absence. It is simply a placeholder, a space where curiosity rests until new tools arrive or new theories or new visitors with clearer signatures. Many astronomers have pointed out that relying on radio signals as proof of artificiality is a narrow view shaped more by the limitations of human technology than by cosmic reality. Life elsewhere may communicate differently. It may not communicate at all. It may build probes that outlive its creators, drifting through eternity without purpose. Silence can be the echo of a lost civilization. Silence can be the strategy of a cautious one. Silence can be the nature of an object with no mind at all. Our instruments do not discriminate. They do not interpret meaning. They only measure. And what they measured in August, September, October and November was consistent, no narrowband tones, no repeating pulses, no structured patterns, no messages. But here is the quiet irony, traveller. A probe designed to appear natural would never broadcast. It would let silence be its disguise. This is not a claim, only a reminder that silence is a wide canvas on which many interpretations can be painted. At the same time, if 3i Atlas is natural, and most scientists believe it is, then its radio silence is exactly what we should expect. Perfectly ordinary, beautifully mundane. So why does the silence feel weighted? Because every other anomaly of this object, its mass, its trajectory, its chemistry, its timing, has created a subtle sense that we should listen more carefully than we have. Not because we expect a message, but because we may be missing something faint, something delicate, something easily overlooked. And that feeling, traveller, is not fear. It is respect. Astronomy is not the search for answers. It is the practice of reverence. Reverence for the unknown. Reverence for silence. Reverence for possibility. When scientists look back on this period years from now, they will not criticise the silence. They will criticise the lack of structured listening, the missed chance to gather a baseline, the absence of coordinated international protocols for studying interstellar objects. Perhaps future visitors will be monitored more carefully. Perhaps new instruments will make silence itself easier to pass. Perhaps we will weigh silence with more nuance, more humility. For now, traveller, the radio sky remains unchanged, a soft ocean of static, a wind across cosmic sand, a whisper that says only listen even when nothing is speaking. This is what the silence from 3i Atlas teaches us. Not that the object is artificial, not that it is natural, but that some mysteries drift past us quietly, offering not answers, but perspective. And in that perspective, you may find peace. Rest now. The sky is quiet, and in that quiet, the universe keeps its secrets gently. Traveller winter draws near, and with it comes the quietest anticipation the scientific world has felt in years. December is approaching like a slow, deep tide, carrying with it a brief opening in the universe, a window of clarity that will exist only once in human history. For 10 days, and 10 days only, 3i Atlas will be positioned just right, close enough to study, far enough from the sun's glare to observe without blindness, aligned with our telescopes in a geometry that will never repeat. It is a moment the cosmos offers only once, like a breath between sentences, and because it will never return, all we can do is listen with everything we have. Imagine the world's observatories preparing for this moment the way monks prepare for a ritual. In Chile's desert mountains, mirrors cool under the night wind. In Hawaii, telescopes rise above the cloud layer into air so thin it carries almost no distortion. Hubble steadies itself in orbit, old but resolute, and the James Webb Space Telescope waits in the deep cold of L2, its gold mirrors angled like a priest's hands, ready to receive the faint warmth travelling from the surface of an object older than Earth. This is not dramatic science as the public imagines it. There are no alarms, no bright lights, no NASA countdowns. It is the kind of science done in whispers, calibrations measured in nanometers, exposures stretching across minutes of perfect stillness, spectral lines appearing as thin as strands of hair. But quiet does not mean small. The data gathered in these 10 days will define our understanding of interstellar objects long after every scientist alive today has returned to dust. As the window begins on December the 10th, Atlas will emerge from its post-perihelion glow. The coma will still be expanding from its closest approach to the Sun in late October, but not so violently that it obscures every detail. The tail will thin just enough to reveal subtler thermal structures. The nucleus, though faint, may show brightness variations as it rotates. Each variation is a clue, one telling us whether the object wobbles chaotically like a natural relic, or rotates with the quiet steadiness of something engineered. Rotation is a language, traveller. Nature writes it in irregular stumbles. Machines write it in intention. But December gives us more than rotation. It gives us heat. James Webb will study how the comet absorbs sunlight and radiates it back into space. A natural object, porous and dusty, warms unevenly and releases heat in complex patterns. But a hollow structure, one with a shell, one with internal cavities, one shaped for durability rather than randomness, would radiate differently. It would trap heat. It would curve its thermal signature. Even without revealing its interior, the skin of the object would betray the story beneath. And so the telescopes will watch for warmth. Not the warmth of life, but the warmth of structure, the warmth of density, the warmth of purpose. Ground-based observatories will focus on the coma, the gases escaping the surface. Natural comets breathe unpredictably, exhaling bursts of water, carbon dioxide, cyanide dust. These breaths are chaotic, shaped by fractures, uneven sunlight rotational timing. But if the outgassing patterns deviate, if gas escapes from a region that should be cold, or if production increases when it should decline, or if jets appear aligned in ways that make no sense for a random object, those deviations will not go unnoticed. Astronomers will see every molecule, every flicker, every anomaly. This is the gift of December, clarity not certainty. And clarity comes only briefly. After December 20th, the object will slide outward into darkness. Its brightness will fade. Telescopes will strain. Webb sensors will detect less heat. The coma will collapse. The tail will thin to near invisibility. By spring, even the largest instruments will lose it. By summer, it will be gone, not in the dramatic sense, not destroyed or dissolved, but simply too distant for light to carry its secrets to us. That is why December matters. It is the last time the universe allows us to ask this question, what are you? Imagine yourself, traveller sitting beside a control panel deep in the night. The room is cool, only the screens cast a faint glow. Data streams slowly from a telescope positioned on the other side of the world. Numbers, graphs, curves, light intensities, spectrograms. Hours pass. You sip cold coffee, your eyes blur, and then suddenly a pattern changes. A line sharpens, a brightness dips. A tail bends a fraction of a degree off the predicted curve, and in that moment you're not just a scientist or a listener, you are a witness. That is what awaits the teams preparing for December, not spectacle, but witnessing. They will watch how the object moves across the sky. Any deviation from gravity, even a small one, will be studied intensely. Outgassing can cause small accelerations, but outgassing has a signature. It correlates with heat, with rotation, with sunlight. If the trajectory shifts in ways that cannot be explained by these factors, then something else is at work. Not aliens necessarily. Just physics we do not yet understand. Just structure we cannot yet see. Science is not built on conclusions. It is built on possibilities. That is why December is a window, not a verdict. It is a chance to gather enough information that future generations can ask better questions. It is a chance to refine models that will one day predict the behaviour of dozens, perhaps hundreds of interstellar wanderers. It is a chance to test the idea that our solar system is not isolated, but part of a greater cosmic ecosystem through which objects drift like seeds in dark air. And yet, traveller, there is another dimension to the December window, one more human than scientific. It is the emotion. Because as scientists prepare for these observations, they carry something unspoken, the awareness that this is the closest humanity has come to an object from another star, and that it is passing by without knowledge of us, without intention, without connection. We are watching something ancient, indifferent, beautiful, something that does not slow down for us, something that will not return. And there is a quiet melancholy in that. For all our instruments, all our equations, all our effort, the December window is not about control. It is about acceptance. Acceptance that the universe will not always give us answers. Acceptance that some mysteries drift past us without ever revealing their centres. Acceptance that looking is its own act of meaning even when understanding does not follow. When the 10 days end, when the window closes, we will not be left with certainty. We will be left with data, with images, with spectra. We will be left with bright lines representing hydrogen, carbon, cyanide, nickel. We will be left with plots of rotation curves of brightness thermal gradients. We will be left with enough to argue, to model, to imagine, but not enough to know. and that is all right. Some mysteries are not meant to be solved. They are meant to be observed. They are meant to remind us of our scale, our fragility, our curiosity. As December approaches, let this truth settle in your chest like a slow exhale. You're living in the brief moment when humanity pressed its face against the glass of the universe and asked a question it was not sure it could answer. You're part of that moment. You're watching with everyone who has ever wondered. You are not lost in space, you are part of it. Let this December be a reminder of wonder, not fear. Let it be a reminder of curiosity, not urgency. Let it be a reminder of silence, not emptiness. For tonight the universe whispers again, and the December window is opening slowly, softly, like an eyelid lifting after a long dream. Rest now, traveller. The cosmos is still watching, and it will keep its vigil long after our brief window closes. Traveller, there comes a point in every scientific journey when the search for answers leads not into clarity, but into a quiet kind of fog. Not the fog of confusion, but the fog of vastness, the recognition that the universe is too deep, too old, too intricate to yield its secrets quickly. With 3i Atlas we have reached that fog. After 6 months of observation, hundreds of telescopes pointed upward, thousands of hours of data and millions of photons captured from an object older than our sun, we stand at the threshold of December still asking the simplest and most haunting of questions. What are you, and what are you made of? We know the coma, we know the outgassing, we know the reflectance, the brightness, the rotation, windows, the approximate mass, the odd chemistry, the improbable trajectory. But those are surface truths, fragments of a language spoken by light. The core of the object, the true body beneath the frost and dust, remains invisible. And invisibility in astronomy is not absence. It is an uncharted interior, a silence waiting to be understood. Consider this, traveller, every measurement we take is a measurement of the surface. Every spectrum comes from gas heated and released. Every brightness curve comes from sunlight bouncing off dust grains. Every image is a shell, a skin, a mask. The interior of 3i Atlas is locked behind millions of years of accumulated material. If it is solid, we cannot confirm it. If it is fractured, we cannot prove it. If it is hollow, we cannot detect it. We are watching a shadow shaped by ancient starlight. Nothing we have, not Hubble, not Webb, not radar, not even the sensitive eyes of ESA's probes can look inside. To see inside would require a spacecraft sent on a rendezvous trajectory, something deliberately designed to meet the object. But we did not have time. We did not have preparation. We did not expect an interstellar visitor of this scale, this mass, this strangeness, and by the time we understood the significance, the launch window was long gone. Space does not wait for our readiness. It moves forward without hesitation. The truth is that 3G Atlas could contain layers we will never touch. It could hide voids or density gradients. It could be homogeneous, a single ancient block of matter. Or it could be a composite object built from materials not found in our solar system. All possibilities exist in the fog, equal in weight, equal in uncertainty. And so we are left with inference, the fragile art of guessing correctly. Inference through heat patterns, inference through outgassing ratios, inference through small accelerations measured over vast distances. This is the kind of science that requires humility, the kind that forces us to say with rare honesty, we do not know. We do not know the true internal structure. We do not know the true composition beneath the surface. We do not know the origin star system, nor how long it has been drifting through interstellar space. We do not know whether the chemistry we see reflects the whole body or only the outer frost. We do not know if the trajectory is entirely natural or influenced by processes we do not yet understand. Even the question of purpose, the one that quietly unsettles the imagination, remains suspended in a place where science cannot reach. If the object is natural, it has no intention, no destination, no narrative. It is simply a relic of chaotic planetary formation ejected from a young system long ago, now passing briefly through ours on its way back into the void. But if it were anything else, a survey probe, a derelict craft, an ancient automaton continuing its mission out of inertia, That purpose would be sealed inside unreachable by instruments tuned only to light and mass and gas. We must hold both possibilities without collapsing into certainty. Scientists often remind each other that absence of evidence is not evidence of absence. But astronomy also teaches us something subtler. Evidence of presence does not always reveal the nature of what is present. The object exists. It interacts with sunlight, with solar wind, with gravity. But what it is remains undefined. This is not failure. This is the condition of observing the cosmos from a single world. Traveller, imagine for a moment the perspective of the object itself, drifting for millions of years through dark interstellar deserts. It has passed stars that lived and died. It has travelled through dust clouds older than civilization. It has been shaped by collisions, by distant supernova shockwaves, by cosmic radiation. And now, after a journey too long to comprehend, it slips through our tiny solar system, one brief passage, one short chapter, before returning to the dark sea from which it came. In the face of such a story, our not knowing becomes humble, even comforting. We are allowed to be small. We are allowed to listen without understanding everything. We are allowed to watch without claiming dominion over the truth. Science at its core is an act of reverence, a willingness to observe without demanding the universe explain itself fully. What we do know, traveller, is this. We know the mass is extraordinary, far larger than expected for an interstellar fragment. We know the trajectory is suspiciously aligned with our planetary plane. We know the planetary encounters, Mars, Venus, Jupiter, cluster in ways that strain statistical expectations. We know the nickel vapour lacks iron, contradicting most known formation models. We know the carbon dioxide dominance is atypical and puzzling. We know the visual features shifted strangely between July and August. We know the timing of perihelion behind the Sun was cosmically convenient for a manoeuvre we could not have seen. We know that the silence from radio telescopes proved nothing neither way. We know enough to ask questions. We do not know enough to answer them. And somewhere in that space between question and answer lies the true beauty of this moment in human history. Because when we look back on this era, months, years, decades from now, we will not remember the certainty. We will remember the uncertainty. We will remember that an object from another star passed by and we watched, we listened, we measured, we wondered, and we accepted that the story did not resolve cleanly. Think of how rare this is. Most of science deals with patterns repeated across time, the orbit of Earth, the boiling of water, the growth of stars. But 3 Atlas is not repeatable. It will not return. It is a single event, a cosmic once-in-a-lifetime visitor. That means our questions cannot be answered by waiting for another observation. We do not get a second try. We must learn from what we have now or not at all. And still, even knowing this, the mystery remains gentle, not threatening, not ominous, just vast. There is a moment near the end of every long night of observation when astronomers step outside their control rooms, look up at the sky, and let the cold air settle on their skin. In that moment, stripped of data and equipment, they feel something deeper than analysis. They feel awe. They feel the smallness of their questions. They feel the immensity of the canvas on which the universe paints. You traveller are being invited into that feeling now. It is all right to not understand. It is all right to rest inside questions. It is all right to drift with the mystery instead of trying to anchor it. Thritia, Atlas moves on indifferent to our curiosity. It does not pause. It does not look back. It follows its long gravitational arc outward and onward, carrying its secrets far from our instruments, far from our reach. But its passing leaves a brightness in our thinking, a reminder that we are part of a living universe, one that still surprises, still confounds, still speaks in half answers and soft riddles. Tonight you are part of that conversation. You are watching from within the fog, patient and calm. You are holding the unknown gently without fear, and the cosmos is holding you back in its quiet, ancient way. Sleep now, traveller. The universe is vast, but it is gentle with those who listen. Traveller, imagine looking at the universe not through equations or instruments, but through a softer lens, one that sees not facts alone, but the faint connections between them. Imagine stepping back from the data, from the charts, from the meticulously plotted trajectories, and allowing the larger shape of things to emerge the way a constellation becomes visible, only when you stop staring at the individual stars. That is where we stand with 3i Atlas, not in a realm of answers, but in a realm of patterns forming quietly at the edge of our understanding. For months now, this interstellar visitor has been telling us a story not in words, but in deviations. Its path through the solar system is oddly aligned with our planetary plane, almost too neatly for random chance. Its near misses with Venus, Mars and Jupiter cluster in ways that stretch statistical comfort. Its mass is unexpectedly high for a body flung through interstellar space. Its chemistry is skewed nickel without iron carbon dioxide, far outweighing water. Green emissions arising where standard comet models predict no such glow. Even its most intimate moment with the Sun, its perihelion, occurred during a 3-week window when Earth could not see it at all. None of this proves anything extraordinary, but all of it together whispers that something is different. And when the universe whispers, "Traveller, we have a choice," listen gently or turn away because the whisper does not shout. Many astronomers choose caution. It is their training, their discipline, their responsibility. Caution prevents premature conclusions. Caution protects against self-deception. Caution keeps science anchored in what can be measured rather than what can be imagined. But imagination has its place too. Not as proof, never as proof, but as the seed from which new questions grow. And the questions raised by 3i Atlas do not arise from a single anomaly. They arise from the accumulation of small ones. Think of it like hearing footsteps in snow. One footprint means nothing. 2 might be coincidence. But a trail, faint though it may be, begins to resemble intention, or at least the possibility of it. Let us consider this trail. A trajectory that behaves more like a deliberate threading of space than a random plunge. A series of planetary near encounters that line up with uncanny timing. A chemical signature that diverges just enough to feel unfamiliar. Brightness patterns that shift strangely between observations. A perihelion hidden behind the Sun. A light curve that resists simple models. A mass so high that it challenges known formation processes. Each of these is explainable. But the complete set strains the boundaries of coincidence. And this leads us to the uncomfortable quiet question at the heart of this chapter. What if the anomaly is not any single observation but the pattern they form together? Traveller, if an interstellar probe were ever to exist, and we speak here only in hypotheticals, not assertions, it would not resemble the sleek machines of our fiction. It would not shine. It would not hum. It would not signal, obviously. It would drift in silence, wearing the dust of 1,000,000 years, indistinguishable from a natural comet. It would become one with time. It would disguise itself in normality, and its anomalies would be buried subtle, detectable only by minds willing to look sideways at the data, not head-on. This is not a claim about 3i Atlas, only a recognition that the cosmos may create mysteries in ways that challenge our models. Natural objects can be strange. Artificial objects, if they exist, would try not to be. Between those two truths lies a frontier of uncertainty, and it is in that frontier that 3i Atlas drifts quietly, almost tenderly. The scientific community stands divided not by conflict but by temperament. Some insist that the anomalies are artifacts, measurement errors, data gaps, or simply rare natural variations, the kind that will vanish into clarity once December's observations are complete. Others argue that even if the object is natural, it represents a category of interstellar debris we have never encountered before, hinting at new astrophysical processes. A smaller few suggest that the object deserves deep structured investigation, not because it is artificial, but because we must never dismiss patterns merely because they are uncomfortable. And beneath these perspectives lies a more human truth: we are not yet equipped to interpret the unknown without first filtering it through the familiar. Traveller, imagine a future in which we have observed hundreds of interstellar objects. Patterns will emerge that today we cannot see. Outliers will be more obvious. True anomalies will stand apart from the rest. But today, with only 3 confirmed interstellar visitors, our baseline is fragile, our expectations speculative, and our sense of normality untested. It is entirely possible that 3 Atlas is the first of many large, massive objects drifting between stars. Perhaps our models are wrong. Perhaps interstellar space is richer with ancient debris than we imagined. Perhaps the strangeness of this visitor is simply the strangeness of the unknown, but it is also possible that this object is unlike the others not by chance but by nature. Not alien, not intentional, just different. And if it is different, then the pattern is not a message, it is a teacher. A teacher showing us that our assumptions are too narrow, our models too limited, our cosmic perspective too young. That is why the pattern matters, not because it proves anything extraordinary, but because it calls us to wonder. It calls us to think the way astronomers rarely allow themselves to think softly, curiously, without fear of being wrong. It asks us to entertain possibilities that challenge comfort but nurture growth. To look at data not just as numbers but as whispers of cosmic history. Perhaps the pattern of 3i atols is a coincidence woven by time. Perhaps it is a clue. Perhaps it is a reminder that the universe does not owe us simplicity. What if the pattern is the message? Not a message from another civilization, but a message from reality itself. Pay attention. Question your assumptions. Do not mistake familiarity for understanding. Tonight, traveller, let your mind rest gently in that awareness. Let the pattern be incomplete, vague, half-lit like a constellation seen through the thin veil of morning. Let yourself drift in the possibility that not every mystery must end in certainty. Some are meant to remain open, spacious, allowing the imagination and intellect to breathe in the same quiet rhythm. You're watching the universe think. You're listening to the soft language of anomalies. You're not lost in the cosmos, you're part of its unfolding pattern. Rest now. The unanswered questions will wait. The pattern will remain. The cosmos will keep its silent watch. Traveller, as we reach the end of this quiet journey, let your thoughts settle like dust drifting through a beam of ancient starlight. December 15th will come and December 15th will go, just as all moments do. But the questions we carry, the wonder we feel, will continue their slow orbit inside us long after the object has slipped beyond our reach. Because what matters is not the spectacle, but the act of looking. Tonight you and I stood together at the edge of the unknown, watching a visitor from another star trace its silent path through our sky. We do not know what 3i Atlas truly is. We may never know with certainty, but the mystery itself is a gift. A reminder that the universe is still alive, still whispering, still unfolding its vast, patient story. And you, traveller, are part of that story. A small observer in a wide cosmos, yet not insignificant. Every question you ask bends the fabric of understanding, even if only slightly. Every moment of wonder is a kind of light. So as this chapter closes, let the silence feel gentle, not empty. Let the uncertainty feel spacious, not frightening. The answers will come in their own time in data and analysis and quiet realizations months from now. For now it is enough that we watched. It is enough that we cared to look. Rest well, traveller. The universe will keep watch. And if this story found you tonight, you may stay for the next.